guys, welcome back to In Case of Econ Struggles. Today I'm going to keep talking about econometrics. I'm going to keep talking about hypothesis testing. Today I'm going to talk about t-test, specifically t-test of means. Again, if there's a specific type of hypothesis testing you want to see, please go down in the comment section and let me know what type of hypothesis test you want me to cover. Otherwise, for now, timestamps are below if you would like to jump around. Let's go ahead and get right into it. So here's the basic idea between t-test and means. You've got two different samples, sample A and sample B. For each sample, you've got a mean and you've got a standard deviation and you've got a variance. You're basically trying to ask the question of, are these two samples coming from the same distribution or are they coming from two different distributions? Now they both could be normal, maybe they've got different means, maybe they have different variances. The ultimate question is, do these two samples come from the same distribution or not? So now, if I just take these two distributions and I plot them together, and again, I assume they're both normal, well, if they look like this, where they're basically right on top of each other, even if they're a little bit off in terms of their expected value, I would say probably this is coming from one distribution. Those things look like they're basically about the same down to some sort of sampling error, and so sample A and sample B are probably coming from one distribution. On the other hand, if the picture when I plot both distributions looks something like this, well, now these expectations, these expected values are very different from each other. It doesn't really look like they're coming from the same distribution, again, up to some sampling error. And so I would say, well, probably they're coming from two different distributions rather than the same distribution in terms of their population values. We can sort of say, well, probably one piece of information that we need to know is how far these two sample means are from each other. Because if they're really far, it's probably two distributions. And if they're pretty close together, maybe it's more likely that they come from the same distribution. I'm going to take that picture we had before between sample A and sample B, where we said probably they came from the same distribution. Now I'm going to draw two different distributions from sample C and sample D, where their difference in their expected value is the same as in samples A and B, but now their variances are much smaller. So this is what it looks like for sample C, and this is what it looks like for sample D, where their variances are just super, super small. Well, if you looked at this picture, you would say, well, sample C and sample D probably came from two different distributions, even though that the difference in their sample means was the same as between sample A and sample B. And in sample A and sample B, we said they probably came from the same distribution. Here, between sample C and sample D, we're saying that they come from probably two distributions because their variance is so small such that this difference in mean seems like it actually means something, and it actually seems like they come from two different distributions. And so with those two pictures in mind, now we know, okay, this difference between the sample means matter, but this variance or the standard deviation in these distributions basically tells you how big or small this difference in the expected value is. Because if the variance is small, then this difference in expected value becomes relatively large, and if the variance or standard deviations are large, then this amount of difference in the mean is probably relatively small. So what we're going to do is we're basically going to come up with a scale difference in means that takes into account how big the variance or standard deviations in our samples is. So now I've got the difference in sample means, and I'm basically just going to divide it by the square root of the sum of the variances, where in each sample variance, I'm just going to divide it by the number of observations that I have in each sample. And we're going to use this formula to just say, okay, the difference in expected values, is that big or is that small relative to how big or small the variance or the standard deviations is in these two distributions? So now if we just apply this to, I don't know, example 1, if this difference is small but the standard deviations are large, then the difference, the scale difference between the two expected values is small and is probably coming from the same distribution. They're probably not two different distributions, which is exactly what we said for samples A and sample B. On the other hand, in sample C and sample D, we had the same level or the same distance between the expected values, but now a small variance, and a smallish number divided by a small number is a big number. So this difference scaled is probably pretty big, and so again, just like we saw intuitively, it's probably pretty likely that these two samples came from different distributions and not the same distribution. So just to sum up what we did before we get into a numerical example, we're just going to compute the scale difference, and then we're going to compare to a critical value, which we're going to get out of a chart or a table, which is going to be based on the number of observations and whether we're doing a one-sided test or a two-sided test. And then we're going to issue a statement like we did in the previous video on hypothesis testing, whether we reject the null or whether we do not reject the null. So now, just for fun, let's do a numerical example, where in sample A and sample B, I've each got 64 cats. In sample A, my average weight is 10 pounds, with a standard deviation of 4 pounds, And in sample B, I've got a sample average of 2 pounds, and I've got a variance of 4 pounds and a standard deviation of 2 pounds. And maybe my null hypothesis is that the two sample means are equal, and my alternative hypothesis is that the two sample means are not equal, so it's a two-sided test. I'm going to use a 5% test, or so I'm going to use values based on a 95% confidence interval, and I'm going to assume normality in the distributions of both of these samples. So numerically, what I'm going to do is I'm just going to take the difference in expected values, which is equal to 8, and then I'm going to take, again, the square root of the sum of variances, where each time I divide by the number of observations in the sample, and I'm going to get 14.3 as my scale difference. That's greater than 2, and on average for a 95% confidence interval, I'm going to get around 1.96 if I'm using a z-score. So I'm going to reject the null hypothesis that the two sample means are equal to each other. So again, this is just a really quick video on t-test. Hopefully it builds some more intuition. If you've got questions, feel free to put that in the comment section below. But if this video or these videos in general are helping you out, please like and subscribe. See you next time for another case of econ struggles.